Hello students, welcome to the next class of chemistry. So we are studying about acids and bases and its chemical reaction also, right? I hope you are studying the chemical reactions, you are writing and studying all the chemical reactions. So topic by topic when you are taking, check which all things are reacting together. In the last class we had discussed what will happen when a metal carbonate react with an acid, right? So take that. So when a metal carbonate react with an acid, what all will be the products? That should come into your mind whenever you see that question. Okay. One more thing that you need to know, concentrate on that particular topics is that sometimes in certain chemical reactions, gases will be evolving out. If any of the gases is evolving out, they are detecting test. How to detect the presence of that gas? That's a frequently asked questions. Last class I have told you about the hydrogen gas, right? How can we test the presence of the hydrogen gas? The same thing, how can we test the presence of carbon dioxide gas? That is also frequently asked question. The answer is that we can test the presence of carbon dioxide gas by two methods. The first method is that pass lime water through it, it will turn milky. So if it turns milky, it is because of the presence of carbon dioxide. We have studied the chemical reaction also for that, right? The next method to detect the carbon dioxide gas is that carbon dioxide is a very good fire extinguisher, right? It's a very good fire extinguisher. Show a lighted candle near to the gas. So if it is turning off, that means it is the carbon dioxide gas. If it is burning with a pop sound, what will be the presence of it? It will be because of the presence of hydrogen gas. Likewise, you need to study. Again and again I am telling you, chemical reactions you have to study by writing. Many chemical reactions that we are studying. Today also we are going to study many chemical reactions. Certain chemical reactions, when this and this is reacting, what will be the product? So for that you have to study properly all the chemical reactions, write and study it. So let us watch today's topic. Study properly, listen carefully. If you are having any doubts, please contact me. Okay, so let's watch today's topic. Okay, so we are going to study the next reaction. Okay, so what we are going to study now is how do acids and bases react with each other. So we are going to study what will happen if acids and bases react together. So what will happen when an acid reacts with a base? So in order to study that, we are doing with an experiment. One activity is there to study about this reaction. How do acids and bases react with each other? For that activity, I have taken in a test tube. I have taken one test tube. Okay, so this is a test tube. In this test tube, I have taken around 2 ml of NaOH, sodium hydroxide. So I have taken 2 ml of sodium hydroxide in this test tube. We know that sodium hydroxide is a base, right? Sodium hydroxide is a base. Now, so I have taken one base known as sodium hydroxide in the test tube. Then what I am going to do next is I am going to add phenolphthalein indicator to it. I am going to add phenolphthalein indicator to it. So when I add phenolphthalein indicator to it, we know that phenolphthaleine's color will be changed to pink in the presence of a base, right? So we have studied that phenolphthalein indicator in a base. When we add phenolphthalein indicator to a base, its color will change into pink, right? So if it is added to an acid, what will happen? It will be colorless. Okay, so this we have studied when we are studying about the indicators, right? So phenolphthalein indicator, if I add it to this 2 ml of sodium hydroxide, what will happen to its color? Its color will be changed into pink. Okay, then what's the next thing I'm going to add is, I'm going to add some amount of hydrochloric acid to same test tube. Hydrochloric acid, the formula is HCl. So I'm going to add hydrochloric acid to the test tube. So now what will happen? So we have added the phenolphthalein indicator. First its color have changed into what? Into pink because of the presence of a base over here. Okay? So now phenolphthalein indicator is there, and slowly we have added the hydrochloric acid. So when hydrochloric acid is added, we can see that the pink color will be changed into colorless. So that pink color is changed into colorless. That pink color will get faded out. Okay. So why is it so? Because of the addition of hydrochloric acid. Now I'm again adding some NaOH to it. So again to the same test tube I have added some more amount of sodium hydroxide. Again sodium hydroxide is a base. So what will happen to the phenolphthalein indicator means it will again change back to its pink color. It will again change back to the pink color itself. So from this activity what can we infer from it? So we can say that from this activity we can say that initially it was only base over here. So that is why the phenolphthalein indicator is showing a pink color. So when we added the hydrochloric acid to it, the base, the effect of the base is nullified by the addition of hydrochloric acid, right? So base was there, so when we added the acid, what did acid do? It has nullified the effect of base over here. That is why phenolphthalein indicator is becoming colorless. The solution become colorless. Again if I am adding sodium hydroxide to it, what happened? Again that pink color has reappeared. Why? Because again the HCl, the action of HCl or the effect of the acid is nullified by the addition of more amount of sodium hydroxide. Okay. Now we can look at what is the reaction that has happened over here. Right? So initially there was only sodium hydroxide. Right? Then I added hydrochloric acid to it. Right? So this is a reaction between sodium hydroxide and hydrochloric acid. So what will happen over here means when an acid, so this is an acid, when an acid reacts with a base, what will be formed over here means this sodium and chlorine atom over the acid will react together and will produce NaCl. So sodium and chlorine react together to produce the sodium chloride. What else is left over here? One hydrogen here and one OH over here. It will together give H2O. It will give the H2O. Okay. So NaOH plus HCl gives NaCl plus H2O. Now we can mark the state in which they are existing. NaOH in aqueous state, hydrochloric acid again in aqueous state, NaCl in aqueous state and water in the liquid state. Okay, so this type of reaction in which a base and an acid reacts together to give out NaCl. NaCl is a sodium chloride is a salt, right? It is a salt, right? So it is a salt. So salt and water is produced over here, right? Salt and water is produced over here. So this type of reaction we call them as the neutralization reaction. Neutralization reaction. So what is neutralization reaction? The reaction between an acid and a base to produce salt and water. is called as the neutralization reaction. So okay, we can write the general formula of it. We can write the general formula of this reaction. That is base plus acid gives salt plus water. So this is the general formula of the neutralization reaction. Okay, so we can take whatever example that we are having. Okay, so for example, we can take another example. I'm taking instead of NaOH, anything else, MgOH twice, magnesium hydroxide. Magnesium hydroxide is a base, so it is reacting with hydrochloric acid. So what will be produced over here? This Mg and Cl will together magnesium chloride. What is the formula of magnesium chloride? MgCl2. So a salt is produced. Right? What else is left over here? Hydrogen and OH is left together. So it is H2. Now we can balance it. Okay, we can balance it. Hydrogen 3 here, right? So balance it. So I can write 2. So it is 4 over here. 2, right? Magnesium 1, oxygen 2, right? Oxygen 2, hydrogen 2 plus 2, 4, 4, right? Chlorine 2. So this is balanced. Again, a base reacts with an acid to produce salt and water. I hope you have understood about the neutralization reaction. So neutralization reaction is a reaction between an acid and a base to produce salt and water. So we have discussed how does a metallic oxide reacts with an acid. So now we are going to study how does non-metallic oxide react with a base. So this we have already studied one example. Okay, a non-metallic oxide. What does that non-metallic oxide indicates? Just now as we have discussed about the metallic oxide, we have studied that metallic oxide means metal in its oxide form. So what will be non-metallic oxide? A non-metal in its oxide form. For example, carbon dioxide, CO2, right? Carbon is a non-metal. So carbon plus oxygen. So carbon dioxide is a non-metallic oxide. So we can check what will happen if it react with a base. Okay, so we studied our calcium hydroxide, right? CaOH twice. So what will happen when carbon dioxide reacts with the calcium hydroxide? So what will be the product? So we have already discussed this reaction before, right? So carbon dioxide, when it is passed through the calcium hydroxide, it will produce calcium carbonate and H2O. This reaction we have studied before, right? Again, when carbon dioxide, a non-metallic oxide, when it reacts with a base, it will lead to the production of a salt. Calcium carbonate is a salt, right? And water also will be formed. Okay, so this reaction is also similar to that of the neutralization reaction, right? So we can just recall it. So a base plus acid gives salt and water. So this is the neutralization reaction. Now we just look at the reaction that we have written right now. Carbon dioxide plus calcium hydroxide. So calcium hydroxide is a base, right? So this is a base. So carbon dioxide, non-metallic oxide, when it reacts with the base, it will produce salt and water, right? So now again look back to our neutralization reaction. We have base over here. It is reacting with an acid to produce salt and water, right? Same products. One reactant is also similar. So carbon dioxide is left over here. So carbon dioxide is a non-metallic oxide. So what can we infer from here? What can we observe from here is that non-metallic oxides are acidic in nature. They are acidic in nature. They have the property of the acids. They behave like an acid. So that is why when a base reacts with a non-metallic oxide, it is producing salt and water. Okay, so non-metallic oxides are acidic in nature, while metallic oxides are basic in nature. So this is really important. This one is really important. Non-metallic oxides are acidic in nature and metallic oxides are basic in nature. Right? Give reason. This is a repeatedly asked question. So what you need to write over here is non-metallic oxides are acidic in nature. Give reason. So if the question comes like that, what you have to write it is that non-metallic oxide reacts with the base to produce salt and water. Hence it is showing acidic behavior. Write an example also. The same one for the metallic oxide also. Metallic oxide reacts with an acid to produce salt and water. Hence it is basic in nature. Give one example also. Okay. Okay, so let us study the next reaction. Reaction of metallic oxides. Reaction of metallic oxides with acids. Reaction of metallic oxides with acids. Okay, so we are going to study about the reaction of metallic oxides with acids. So before studying about how does a metallic oxide reacts with an acid, first we need to know what is a metallic oxide. So metallic oxide, what is meant by a metallic oxide? So from the name itself it should be understood that metallic oxide, right? A metal and an oxide. Metallic oxide. A metal in its oxide form. So metal in its oxide form. Metals in its oxide form, we call it as the metallic oxide. For example, copper oxide, metallic. A metal should be taken, copper oxide. Copper oxide is an example for metallic oxide. A metal is taken. Then sodium oxide, Na2O. Again, one metal is the sodium and oxygen, right? Na2O. Magnesium oxide, another metallic oxide's example, right? A metal is the magnesium and an oxygen. So these all are the examples for the metallic oxide. So we are going to study what will happen when a metallic oxide reacts with an acid. Okay, so let us take one example. Any metal oxide. Suppose I have taken copper oxide. So what will happen when copper oxide react with an acid? For example, hydrochloric acid. I have taken hydrochloric acid. So when we mix hydrochloric acid with the copper oxide, we can see that after some time a bluish green color is appearing. A blue-green color is appearing. Why does this blue-green color is appearing is that it is because of the formation of copper chloride. As we discussed in the last example, this copper and the chlorine will react together to form copper chloride, CuCl2. Plus, what else is left over here? Hydrogen and oxygen, right? So, water also will be formed. CuCl2 plus H2O. So this is what has happened over here. This blue-green color is because of the formation of copper chloride. Okay, so now we look at this equation again. Is it balanced? No, right? Copper is balanced. Oxygen, yes. Hydrogen, no, right? Hydrogen here, 2 atoms of hydrogen is there. Here only 1 atom, right? So I wrote it as 2. Chlorine, yes, now it is balanced, right? So what can we get it from here? When a metallic oxide reacts with an acid, it will produce a salt. CuCl2 is a salt and a water. So okay, we can write the general equation. We can write the general equation like this. Metallic oxide
plus an acid, metallic oxide reacts with an acid to produce salt and water. So now you look at this general equation. Have you seen this equation before? And something plus something gives salt and water, right? We have studied it before, right? Just now we have studied it in the neutralization reaction. Just recall what is neutralization reaction. Neutralization reaction is a reaction between an base and an acid to produce salt and water. So this was the reaction of the neutralization reaction that we have studied just now, right? So this equation is also similar to that, right? The same products are forming, right? Salt and water is forming over here. Here also salt and water. Here also acid is there. Here also acid is there. So what else is left over here? Only one base is left over here, right? So from this equation we can say that a metallic oxide is having a what nature? This is having a basic nature. It will behave like a base. It will behave like a base. So we call it, say that metallic oxides are basic in nature. Why metallic oxides are basic in nature? Because it will react with an acid to produce salt and water, just like how a base is reacting with an acid to produce salt and water. I hope it is clear. So when a metallic oxide reacts with an acid, a salt and water will be produced over here, right? So just like the equation that we have studied before, base plus acid gives salt and water, right? So we can say that metallic oxides are basic in nature.
So we have discussed some chemical reactions. Now we can discuss some textual questions also. Okay. Let us start discussing the textual questions. So the first question is, why should curd and sour substances not be kept in brass and copper vessels? So curd or any other sour substances we should not keep in brass or copper vessel. What is the reason for it? The reason is that curd and sour substances, they are normally acidic in nature. So if we keep them in brass and copper vessels, brass and copper both contains metals present in it. So metals will react with the acid, and what will happen? Metal plus acid liberates hydrogen gas, and if the hydrogen gas is produced, it is not good for our health and it will result in the spoiling of food. Okay, so why should curd and sour substances not be kept in brass and copper vessels? Curd and sour substances are acidic in nature. If we keep them in brass and copper vessels, metal of their container react with the acid and liberates hydrogen gas and harmful products. This results in the spoiling of food. Next question. Which gas is usually liberated when an acid reacts with a metal? Illustrate with an example. How will you test for the presence of this gas? So our question is, what is a gas which is produced when an acid reacts with a metal? We know that when an acid reacts with a metal, hydrogen gas will be produced. We have to illustrate this with an example. For example, sulfuric acid. So an acid is reacting with a zinc metal. Okay. So what will produce? ZnSO4. Zn and SO4 will react together to give out ZnSO4 and the hydrogen gas will be evolved out. Now, how can we test the presence of this gas? So we can test this evolved gas by its burning with a pop soap when a candle is brought near the soap bubbles. So in order to find out which gas it is evolving out, we are reacting this metal and an acid, and the gas which is produced, we are collecting it in a soap solution. So in the soap solution, bubbles will be formed because the gas is formed over here. So these bubbles will contain the hydrogen gas. So a lighted candle, if it is shown near to the soap bubble which contains the hydrogen gas, it will burn with the pop sound. Next question. A metal compound A reacts with dilute hydrochloric acid to produce effervescence. What is meant by effervescence? Means bubbles. Bubbles are forming from the bottom of it. So that bubbles forming, we call it as a escaping of the bubbles. We call it as a effervescence. Why these bubbles are forming? Because a gas is produced over here. So a metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. Okay, so it's a reaction with a metal and an acid. So a metal compound, so it is not purely a metal, it is a compound of a metal. Okay, so the gas evolving out is extinguishing a burning candle. That means that particular gas has a capability to extinguish the fire. So which gas is extinguishing the fire? Carbon dioxide, right? And another product they have given it is calcium chloride. So calcium chloride is the, so this reaction we have studied, salt and a gas is produced, salt and carbon dioxide gas is formed over here. So which reaction is that? Yes, it's a reaction with the metal carbonate and an acid. Since calcium chloride is formed over here, which carbonate that we have used over here? It will be calcium carbonate plus HCl. It will produce calcium chloride, carbon dioxide, and one more product is the, what is that? Water. Water is also formed over here. So this is how you need to predict out the chemical reaction. That is why I told you to study each and every chemical reactions. We have studied that a metal carbonate react with an acid to produce salt, carbon dioxide gas and the water.